Good morning. Chapter 13, Lesson 4 is on page 593. Today we finally get to the quadratic formula. And I put it on the right-hand side there, ax squared plus bx plus c is equal to 0. And we're going to be looking for the coefficients for a, b, and c, and we're going to be plugging them into that formula. X is equal to, in the numerator, negative b plus or minus the square root of b squared minus 4ac, all that numerator divided by 2 times a. The other thing we need to remember is we're going to be talking about the discriminant, which is the thing under the radical, the b squared minus 4ac, and it can have three different values. It can either be positive, it can be 0, it can be negative. And these crude parabolas I drew show you that for positive discriminants we have two roots. For a 0 discriminant there is only one root, and for a negative discriminant there are no real answers, and we don't know how to solve that problem. So let's start off with number 19, 4y squared plus 3y minus 1. All we got to do first is find out what the coefficients are for a. Oops, let's get to black. For a, for b, and for c. And for a we get a 4, for b we get a 3, and for c we end up with a negative 1. So let's plug them in. So we've got negative b, let's write it down, x is equal to negative b plus or minus the square root of, no shortcuts, let's just do it all, b squared minus 4ac, all that divided by 2a. So it's just a matter of plugging stuff in, so we end up with x is equal to negative 3 plus or minus the square root of 9, that's 3 squared, minus 4 times 4 times a negative 1. So 4 times 4 is 16, and that becomes positive, so we get 9 plus 25, so we end up with x is equal to negative 3 plus or minus the square root of 25. Oops, and I forgot to divide all that by 2 times a, which is 8. So that gives us negative 3 plus or minus 5. All that divided by 8. And remember, in a quadratic, we can have at most two answers. So negative 3 plus 5 is 2 over 8. And negative 3 minus 5 is negative 8 over 8, or negative 1. So our answers turn out to be 1/4 and negative 1. I forgot to reduce the 2/8, but that's okay. Number 43 says, let's take a look at a squared plus 12a plus 36. And it says predict, using the discriminant, the number of real-world solutions. So what that means is we're going to have to play with the discriminant, and that's all we have to do, because the discriminant, based on the right-hand side, values being positive, 0, or negative, will tell you how many answers we're asking for. So they're just asking us in 43, how many answers do we have? Well, obviously a is 1, b is 12, and c turns out to be 36. So our b squared minus 4ac is the only thing we have to pay attention to. So we stick in a 12 squared minus 4 times 1 times 36, and that turns out to be 144. Take away 144, or 0. So our discriminant is 0, so there are only going to be one real-world solution based on graph number 2. Okay, so that's what that one looks like. This lesson is so important, I'm going to do one more problem. That problem is number 63 on page 584, and it says use a graph now to find the roots. So they don't even want you to use the quadratic formula. They're saying, you know what, there's also lots of ways to make these things with pictures. Sometimes are very helpful as well. So x squared plus 1 is the quadratic function they give us, so we're going to turn that into y is equal to x squared plus 1. It's the same thing as saying the function of x is equal to x squared plus 1. So we're going to make our famous t-chart for one of the last times. I think we're getting a pretty good hang on all this stuff. I'm going to fill in a few points this time just to make sure we got x and y, so we can see what our trend is going to look like. I'm going to go with 0. My favorite numbers, 1, 2. Guess I might as well throw a negative 1, negative 2 in there for chuckles as well. If x is 0, obviously y is 1. If x is 1, y is 2. If x is negative 1, y is going to be 2. And if x is 2, y is going to be 5. And for negative 2, it turns out to be the same thing. Remember, when we square a negative number, we get a positive number. So that's why the graph looks like that. So I'm going to go with 0, 1. And obviously, my graph is going to be too small. So what I'm going to do is change the scale, make this 0. I'll make this... I'll make these in halves. How's that? So this is a half. So this is 1, this is 2, that's 3, this is 4. So I'm going to change, these are 5. So that's 5. So there's 5, 4, 3, 2, 1. What I did was I just changed the scales. The scale I turned to be in halves. So that's what it is. So everything here is in halves. So here we go. We got 0, comma 1. Let me do that in red so we can see what this is going to look like. 1, comma 2. I better mark myself to make sure I don't make a mistake. 1. 1, 2, 3, 4. So we got 0, comma 1. Okay. We got 1, comma 2. We got 2, comma 5. We've got negative 1. Comma 2. And we've got 2, negative 5. So my graph looks something like that. Let me try this in lime green. So we're going to try to connect the dots, and I'm probably not going to do a very good job, but practice, you'll get better. So there's my parabola. So the parabola looks like it never touches the x-axis. So this must be one of those situations where there are no real roots, because it never does touch the x-axis. Remember, on the previous page we had 3 different ways we could have if the graph touched the x-axis, at least one solution. If it crossed it, there were 2. That was example 1 and example 2 on my notes on the right hand side. And if it never crossed it, there were no real solutions. So for this one, number 63, it says, let me just verify that. Find the roots of each polynomial. There are no real roots for this problem. Let me make sure. So there we go. Thanks so much. See you all tomorrow.